Today I'm finally getting around to installing my solar panel. This is a 100-watt solar panel I purchased off of Amazon. It comes with a pigtail here with these MC4 connectors, so I'm going to have to make an extension that's going to run down the rack and into the AC unit there. I'll take off the hood and I'll show you, and I'll also include the links to these products. So as you guys saw in my previous video, if you guys remember, I stubbed out some wires here for future lights. Well, I ended up using them. As you see here, I used some heat shrink connectors here. They're pretty cool. They crimp on really nice, and you use a heat gun and they shrink around it to make it a little bit watertight since it's going to be up here. And here is my solar cables. And I had to add these MC4 connectors because that's what my solar panel uses, and it seems to be pretty standard in solar panels. Pretty easy to install. So I got to go make that extension that's going to run from here all the way to here. Okay, so your solar connectors are basically comprised of a male and female connections. And be careful when you open these up. Remember the order of how these go together. Now remember, as soon as I make that connection up in the roof, these wires that are down here inside the van are going to get hot. So take precaution. We don't know which one's going to be hot, which one's going to be neutral yet, or ground. So just make sure you're careful with that. All right, let's go hook it up top. Okay, so you have a solar panel, and from what I understand, that solar panel can vary on the voltage throughout the day depending on the sun, so you have to somehow regulate it. Now I chose to use the SC230, which is going to work in conjunction with my trimetric unit. As you see here, it's got a data cable. It's basically a phone cable that's going to run into that trimetric unit so it can talk to it. And here also we have another accessory, which is a temperature sensor for your batteries. So this will connect to one of the positive leads, and it'll tell the controller what temperature your battery is at. If it's too cold, it'll tell it, hey, it needs to bump up the voltage, or vice versa, so you can get the best charging rate for your batteries. So again, a basic solar panel setup, you're going to need a solar panel, and you're going to need some way to regulate the voltage. This here happens to be a multi-stage solar charger. So what it's going to do is it has the different phases of charging. This solar charger actually also has a desulfation process, which allows you to overcharge your batteries. They recommend about 15 to 16 volts with small amount of amperage. And what that's going to help do is your batteries, if they don't get properly charged all the time, which in my case, because it's in a moving van, the batteries don't get charged fully all the time, it starts to develop sulfates on the plates inside the batteries, which are, from what I understand, these crystals that kind of adhere to the plates and don't allow you to, well, basically won't allow your battery to function to its best. And the more you get on there, the worse the battery is going to get. So with this charger and many other chargers, you can choose to have it overcharge your batteries, and it'll help knock off those crystals and bring your batteries back to their optimal state. Okay, so now we just need to figure out which one's the positive and which one's the negative. It's always nice to have a multimeter so you can figure that out. The manual said you can test it, and if you see a negative, that means your probes are reversed. And when you don't see a negative, that means everything's correct. So that tells me that this one is my positive and this one is my negative. I made sure which one was positive and negative. They just get connected here. As you can see, it's labeled positive and negative. So before the positive enters here, I ended up putting in a 20 amp breaker here because it is a hot line. So just to be safe, you want to put some kind of fuse. 20 amps, and the 10 gauge wire is a little overkill for one panel. In the future, if I decide to add more, it shouldn't be a problem. The negative comes into the negative side. Now on this side that's labeled battery, as you notice here, I got the hot, and what I did was, instead of running all the way to my battery is a little bit hard to access. What I did was I ran the hot right to this Blue Sea fuse panel that I have right next to the solar charger, because this line here essentially goes right to the positive terminal of the battery. Same thing with the negative, came around to here, which this negative cable is pretty big too. I believe it's either 4 gauge or 6 gauge. Runs directly to the battery about 2 feet away. So in essence, these are actually connecting to the battery terminals via these connections here. Everything seems to be working good. I got a yellow light indicating my panel is getting sunlight. The green light will blink. It'll tell me what phase the multi-phase charger is in. And like I said, pretty straightforward. And one of the main reasons why I went with this SC2030 from Bogart Engineering is because via that telephone cable, it talks to my panel. Okay guys, looks like we're getting some power from our solar panel. My battery's about 100% full, so when your battery's full, it doesn't require much amperage, and the sun is starting to go down. It's at 13.3 volts. I think it's at the float stage right now. So there is something awesome about getting power from the sun when you're off the grid. You almost want to add more solar panels, but you're limited on how much room you have on your roof. In my case, I have a roof rack, so I don't want to take up all the room with solar panels. But it is great to know that while my van's sitting out there, it's getting anywhere from 4 to 8 amps throughout the day, kind of topping off my battery. There's two reasons I'm really liking what this system is doing right now. One of them is that I have a battery charger, a NOCO battery charger, but because our vehicles are moving, or my van, I got to go to work, run errands, it can't sit there and charge completely all the time. And as you know, and I'm finding out, the worst thing you can do to your batteries is not charge them to 100%. So what I think this solar panel is going to do is help with that whole process. So wherever my charger ends up, maybe 75% full, and I unplug my vehicle and have to go run an errand, while it's sitting out in the sun, it's going to top it off and hopefully finish the charge so that my batteries get that 100% charge. The second thing I'm really liking about having the solar panel is the fact that the solar charger that I'm using, I can have it go into that desulfate stage or the equalize stage, and it's very easy on this system. I just hold down, look for DSE, which stands for days since last equalized. I reset that and I hold this down for about 5 seconds. You'll see the EQU flashing, which is telling me that it's now in that phase. And what we should see here is the voltage starting to creep up. Well, while it's doing that, I'd like to say thanks for watching my video. Make sure you like it. If you have any comments or questions, let me know, and I'll keep making these videos. I make these videos in the hopes that it helps you guys out. I did a lot of research online and reading, and I'm finally able to put things together for my van. So if it can help you guys out, that's great. Again, here it is at 16 volts, and it'll continue like that for about 2 hours and then revert back to its normal float stage. Almost all battery manufacturers now are recommending that you do this fourth stage or equalizing stage to your batteries to help with the longevity of our batteries.